Okay, so let's get into solving equations. So we have been solving equations. Definitely what we've just done is solving equations, but we're going to get into a little bit more advanced equations here. So just like we've learned in the previous sections, we're still going to follow those rules of algebra, okay? But now we're going to get into expressions or equations rather that have more than one variable in it. So remember how in Unit 1, Algebra Unit 1, a few PowerPoints or videos ago, we learned about combining our like terms and the rules of addition and subtraction and the rules of multiplication division. So we're going to tie all of that together with our solving equations, and we're going to make it into just sort of, we're going to just combine it all and hopefully make sense of it. So our steps in these equations is to make sure that, or move all of our like terms to one side of the equal sign. So you can either move it to the left or the right, doesn't matter, as long as you're moving all of your variables to one side and then all of your numbers to the other side. So we want our variables on one side and our numbers on the other. Once we've done that, we can add our like terms. Okay, so we're going to combine our variables on one side, and then we're also going to combine our numbers or our constants on the other side. And we can repeat these steps if necessary, and then we solve. And how do we solve? We solve using the exact same steps we just used earlier in this video. So we do our addition and subtraction first, multiplication, division, and so on. So this video is basically just going to be a ton of examples from me. It's mainly just examples because really that's the best way to teach this kind of thing. So there'll be plenty of examples today. So let's get started. I'm gonna just use black this time. Okay, so according to our rules before, we want to move all of our variables to one side of the equation. You can choose the left or the right. In this one, I like to choose the side that has more x's. So on the right hand side I have 3 x's, and on the left hand side I have 2. And the reason for this is because then I don't have to deal with a negative value attached to my x, but it really doesn't matter. So I'm going to bring my 2x over here, and I'm going to bring this -2 to this side. So I'm going to bring all my constants, all my numbers to the left side, and my variables to the right. And in order to do that, it's just following our same rules and looking at what's happening. So this is a 2x that's essentially being added. So some teachers like to say when I bring this across the equal sign, it flips values. So my 3x is going to stay there, and that 2x, which was the positive 2x, right? We didn't write one there, but there is one there, is going to become -2x. So to bring it across the equal sign, we have to do the opposite of what's happening. And then the same goes for the value -2. So the 2 is being subtracted. I have a 4 here still, but I'm going to add 2 to this side because we're doing the opposite of what's happening, okay? You don't have to do this all at once. You can do this in 2 steps, in multiple steps if you'd like, but it's essentially going to be the same thing. So 4 plus 2 is going to give me a 6, and then 3x take away 2 is just going to be a single x. So I'm actually done. So I get that x is equal to 6. Okay, so we have the same thing happening here. I have 8 x's on the left-hand side and 6 on the right, so I'm going to bring this 6x over. The 6x is actually being added, right? So it's a plus. So I'm going to keep my 8x here. To bring it over, it's going to be -6x. And then, so I'm going to bring that over to this side, and I'm going to bring this guy over here. So it was a -1, so to bring it over or to get rid of it, we're going to add 1. Right, so similar steps as what we had earlier in this video, but in this case we just have multiple variables. So 8x take away 6x is going to give me 2x, and 13 plus 1 is going to give me 14. Now the question is, am I done? No, because again, my goal is to always have that variable is equal to something or something is equal to the variable. It doesn't matter if it's on the left or the right, but there can't be a number being multiplied by it or subtracted or anything happening to it. We just want a single x. So in order to get rid of this 2, I'm just going to switch colors here. we're going to divide this side by 2, and whatever I do to one side, I want to do to the other. So I'm going to divide this side by 2 and the other side. So that 2 goes away, and then I'm left with 14 over 2, which is 7. So I have x is equal to 7 as my answer. And just a reminder, we haven't done this class, but you can sub the 7 into this side and check your answers if you'd like, right? Because you want that left-hand side equals right-hand side. So maybe let's do that just for this one. So I'm going to erase this. So just because I didn't have room, we found that x was equal to 7. So now let's check. So I'm going to sub in a 7 on this side and a 7 on the other side. So anywhere there was an x, I'm going to sub in a 7. So now we're just going to do the math, and remember our goal here is to get that my left-hand side equals my right-hand side. So we have 8 times 7, which is 56, take away 1, and then 13 plus 6 times 7, which is 42. So 56 take away 1 is 55, and then 13 plus 42 is 55 as well. So we get left-hand side equals right-hand side, so that means we did pick the correct value. So good work. Okay. So those were, I hate to use the word simpler examples because I do realize algebra is hard. Like everything is very hard. And I don't want to take away from that. But now we're going to move on to equations that have brackets. So solving equations with brackets. So sometimes the question is going to have brackets in it. Sometimes there's just one bracket. Sometimes there's multiple brackets. Sometimes there's a binomial in the bracket. So in this case, we have 2 binomials, right? That means 2 terms. Sometimes there's a trinomial, etc. So what we've learned so far is the expansion rule or the expansion method, right? So we know that whenever we have a value outside of a bracket, we have to bring this value through to both of the terms, so all the terms inside the bracket. So we have to use our expansion rule. So this goes back to your multiplying booklet. So if you need a refresher, you can go back and review that video, or you can go back and look at that booklet, which is in the Algebra 1 unit under, I think, the multiplying booklet. So the first step in this question is to get rid of the brackets, and in order to do that, we're going to multiply it through whatever polynomial is in here, or expand the expansion rule. So let's try one. Okay, so we have a 2 on the outside of this bracket. I'm just going to switch the color here. So we have a 2 here, so we're going to bring the 2 through both sides of the bracket, and we're going to do the exact same thing with the 5 here. So we don't want our brackets, we can't just go start subtracting 4x from the side or anything like that, because whenever something's in brackets, I need to release it from the brackets before, because I actually don't just have 4x's on this side, I have 20. So I'll explain why in a minute here. So we're just going to do, so 2 times 3x gives me 6x, 2 times negative 4 gives me negative 8. No x, just a negative 8. Then we have equal sign, so we're going to write that exactly as is. 5 times 3 gives me 15, and then 5 times 4x gives me 20x. So I've expanded my bracket. So I did that first step. Now we're going to go back to what we just were talking about, and we're going to get all of my variables to one side and all of my letters to the other. So I'm going to bring the x over here just because I like to bring it to the side that has more. And I'm going to bring my 15 to this side. So I get 6x, take away 20x because it was a positive over here, right? Equals 15. I had a minus 8 here, so I'm going to add 8. Oops, I forgot to put an X there, sorry. So I'm going to get negative 14x on the left-hand side. And then 15 plus 8 is going to give me 23. It's weird, I thought we would have, is that right? 6. Yep, okay. Okay, it's not going to give us a nice even answer, but that's okay. Okay, so negative 14 we're going to divide by negative 14 on both sides to get rid of that. That's why I'm confusing me. I told you that I was going to do the other way. I was going to bring the 20x, I was going to bring the 6x over here and the 5 over there. I am so sorry. It's right. It's just that that's not what I told you I was going to do. Is it? So what I did instead was I brought the 20x over here, which is good because now I can see an example with a negative. And then I brought the 8 over here. So it doesn't matter. I brought my x's to the left and my numbers to the right. So I did the opposite of what I said I was going to do. But either brought the 8 over here. So it doesn't matter. I brought my x's to the left and my numbers to the right. So I did the opposite of what I said I was going to do. But either way is right. So that goes to show that it'll still give you the same answer. The problem though is I get that negative 14. So I risk not remembering to divide by that negative, which is why I tell students to typically do the other way. But if we're doing that, we just have to make sure in our calculator we're going 23 divided by negative 14. So either you're going to get a decimal or a fraction. So I'd get 1.64. So usually we round to 2 decimal places. Or in fraction form, we have 23 over 14. Your calculator might give you, oops, as a mixed fraction. What is happening? Oops. 1 and 9 over 14. Negative, rather. Or negative 23 over 14. All of these are right. All of these are correct answers. So whatever your calculator gives you, I'm happy. I will accept any of those answers. So just to be clear, there's not three different answers. These are all the same number. So this is 1 and this is called a mixed fraction. So negative 1 and 9 over 14. This is negative 23 over 14. So this is what we call an improper fraction. And then this is just our decimal. So every calculator kind of spits out something different. That's why I wanted to say that. Okay. Now we are getting into equations with fractions. So whenever we have an equation that has a fraction, there's two things we can do, sort of, essentially. There's two types of fraction questions. The first one is that we have a fraction on both sides of the equal sign. So I have a fraction on the left-hand side and a fraction on the right-hand side. So what does that mean? What does that mean in terms of what we're going to do? So if I have a fraction on one side and a fraction on the other and no other terms around it or being added or multiplied, we can use cross multiplication, and I'll explain that in one of our examples. However, if we have an example where you can see that there's a fraction on this side and there is a fraction on the right side, but there's also another term being, in this case, added to it, right? Or you could say the negative v over 4 is being subtracted from the 4. We can't just do cross multiplication. We have to find what we call a lowest common denominator, or any common denominator. It doesn't have to be the lowest, and I'll talk about that in one of the examples. So that is basically like what's going to happen here. So we're going to look and see. So we have one fraction on the left-hand side and one fraction on the right-hand side. So I'm just going to actually write this bigger. Oops, that's not what I wanted. Okay, so oops. We have u over 2 is equal to 3 over 5. So again, if you don't like the letter u, you could use an x here. So for cross multiplication, it's exactly as it sounds. We're going to multiply across the equal sign. So we're going to multiply these two terms together and these two terms together. Okay. Doesn't matter which one you do first. I could do 3 times 2 on this side or on this side, right? So I'm going to do, I could do, it doesn't matter which one you put on the left or the right, but we're going to do a u times a 5 and then an equal sign. And then we're going to do the 3 times the 2. So I did these two multiplied, which gave me u times 5, and these two multiplied, which gave me 3 times 2 or 2 times 3. Again, doesn't matter. the order. So we know with a constant times a variable, we're just going to get a 5u. There's really nothing special we can do there. And then we get 3 times 2 is 6. Now, that doesn't mean we're done, right? We're always looking to see, is my variable by itself? And it's not. So there's a 5 being multiplied by the u, so we're going to divide both sides by 5. And we get the answer of u is equal to 6 over 5. Or 1 1/5, or whatever the decimal version of it, which is 1.2. You might have also got 1.2 in your calculator, or 1 1/5. All three are acceptable answers. Okay, so this one, it's a bit tricky, right? So we actually do have two fractions only, but this negative 8 over 5, I'm going to bring over to the other side of the fraction. So I had a 9 over u, but I'm going to bring that minus 8 over 5 over. So when I do that, it becomes a positive 8 over 5, right? So when I bring it over, it switches signs. Now I have a question where I can just do my cross multiplication. We try to do cross multiplication as much as we can because it's really it saves you a lot of time on the on the solving in the equation. It just saves you quite a bit of time. So I'm going to do my 9 times 5 on this side. I could have also done the u times 8, doesn't matter. And then on the other side, I'm going to do my u times my 8. So 9 times 5 is 45. And then u times 8 is just going to give me that 8u. And now the question is, am I done? And I'm not done, right? So my next step is to get rid of that 8. So I'm going to divide this side by 8 and this side by 8. So 45 divided by 8, it's going to give you 5.625 or 63 is equal to u, or it will give you a mixed, mixed fraction, which is 5 5/8. Or it might just keep it as 45 over 8. That's correct too. All three of those are correct. If you're going to do decimals, typically we say to round to 2 decimal places. You can give me as many decimals as you want unless the question says what to give. It's totally fine. Oh, isn't that the one I just did? Oh, I accidentally have the same slide twice. Okay, we're going to skip that one. Okay, so we have the same thing happening here. So we're asking ourselves, is there one fraction on the left and one fraction on the right? And if so, then I'm going to use cross multiplication. And there is. So this one's a little bit messy. It has brackets, but still we have two fractions, so we can cross multiply. This one just becomes a little bit trickier in terms of the algebra that I'm using. So should we expand it first? No, we're going to keep it like this. So on the left-hand side, I have a 1, and then I have a 2x plus 4 equals 5 times 3x. So 1 times anything is itself, right? So essentially, we just have a 2x plus 4 on this side and a 5 times 3x on this side. You could have also multiplied the 1 and the 2 together. Either way, we get just a 2. Now, we have a little bit of a harder one on the left-hand side. We need to remember whenever I have brackets and I have a polynomial inside of it, I have to expand and simplify those brackets. So 2 times x gives me 2x. 2 times 4 gives me a positive 8 equals 5 times 3x gives me 15x. Now we're going to go back to the rules of getting all of our x's to one side. So I'm going to bring my x over to this side. And I don't have any other numbers here to bring over. So I'm going to be left with an 8 here. I have my 2x now flip signs, so negative 2x or subtract 2x. Oops, there's an x there. So we get 8 is equal to 13x. And then my last step is to get rid of this 13. We get 8 is equal to 13x. And then my last step is to get rid of this 13. We divide this side by 13 and this side by 13. And I'm just going to write one of the answers. I'm going to write the decimal. 8 divided by 13 is 0. We'll do 2 decimal places, 62. or you could have kept it as 8 over 13. Those are both right. Okay, so we make sure we're expanding through the brackets. This one's a hard one. I think you have something similar to this on your assignment. So just take it step by step and show me as much work as you possibly can so that I can give you as many marks as I possibly can. Okay, so now we have a situation where I have a fraction and another fraction, but there's this number here in between. So this flags me that it's not my first type, right? So it's not the type where I can cross multiply because this 4 is sitting here. So this is like a type 2, I guess we could call it, the second version of what we're looking for. So according to our rules, in this version, we have to find our lowest common denominator. Denominator. We usually just call it, and I will continue to call it, an LCD, just because it's way too much to write out. So your lowest common denominator is a number that both of the sorry, I shouldn't say both. Some questions have more than 2. In this case, we have 2 denominators. So we have a 3 and a 6 on the bottom, right? And we need to pick a number, and you'll see why, that they can both go into. We like to use the lowest one because it just makes our numbers easier, but you could use any number that either of these can go in. So when I see this, I look and say that my lowest common denominator is 6, because 3 can go into 6 and 6 can obviously go into 6. It's just itself. But we could have also used 12, we could have used 18, and so on. So because 3 goes into 12, 3 goes into 18, and 6 goes into 12, and 6 goes into 18. So we could have used those as well. We're going to use 6 though. So what I'm going to do here is I'm going to multiply every single term by 6, by my lowest common denominator. Maybe I will write it in a different color. I'm not sure if that's helpful to you, but I feel like it would be helpful to me. So we have a 6 here. Oops, what did I just do? 3a take away 6 over 3 equals, and then I also have a 6 here times 4. Take away, I have another 6 being multiplied here, a over 6. Sorry, my a's sometimes look like 9s when I use this thing. Okay, so now we do what's called cross reducing, which basically means that the reason I did this is to get rid of my numbers on the bottom. I can't solve for x with these denominators. It's a disaster. It's a mess. So this 3 and this 6 we're going to simplify. So 6 divided by 3 is just a 2, right? So you can also think of it as 3 goes into itself once and 3 goes into 6 twice, but it's easier to just think of what is 6 divided by 3? It's 2. And then here, what's 6 divided by 6? It's a 1. So that's what we're left with. That's why we did it. So instead of writing all of this, I have a 2, because these two reduced to just be a single 2. And then we get 6 times 4 is 24. Now on this one, I just had a 1 outside and I'm only left with an A. So I'm getting closer to the answer, but I still have a ways to go. So I need to bring this 2 through my brackets because I know that I can't just move things around until they're released from these brackets. So 2 times 3a gives me 6a. Take away, so 2 times 3a is 6a. 2 times 6 is negative 12. We have 24. Take away a. So I just simplified the 1 times a there. So let's bring my a over to this side. So I'm going to add a to both sides. And then I'm going to add 12 to both sides because I'm going to bring it over here. So you can write up top what you'd like to do. There's various ways to do these. Oops, that's not right. I'm sorry. Get rid of that. So I decided, oh no, that was right. See, maybe that method doesn't work for me. I'm going to bring this way and this way. So we have 6a plus a equals 24 plus 12. So I brought the 12 this way and the a this way. But again, it doesn't matter. You could have brought your a's to the right-hand side. So 6a plus a, this is our rules of addition. So we just add those coefficients, 7a. 24 plus 12 gives me 36. And then my last step is, I'm gonna have to write it up here, sorry. This is why I tried to use the PowerPoint because I have way more space, but. So we had 7a, oh, that's really messy. So we have 7a equals 36. Now I'm gonna divide by 7 on both sides. And then I'm gonna figure out what is 36 divided by 7. It's not gonna be a nice number, but it's fine. We're gonna do 5.14, or you could leave it as 36 over 7. Both work. Okay, so to recap, we found our lowest common denominator, which happened to be 6. We multiply every term. So this is its own term, this is its own term, and this is its own term. So we multiply each one of these by the value we've chosen, in this case 6. Once we've done that, we're going to cross reduce. So that's why 6 divided by 3 becomes a 2, and this one becomes a 1. Then we write down what we're left with. So this 6 over 3 is gone. It's now just a solid 2. And then over here, the 6 over 6 is gone, and it's just solid 1. So we're just going to write out what we're left with. Then we can do our expansion if we need to, which we've done. And then we can bring our variables to one side and our numbers to the other. And then we see if there's any other steps we need to do to solve for a. Typically, it's a division step. Sometimes, though, it can be square root. Sometimes, yeah. Every question in algebra is a little bit different, which I think is why typically students don't love this. Okay, so we have 2 more examples left, and then we're done for today. And I do recommend, like, if you want, you can re-watch these videos, right? You can back up and watch the problem again and see if it makes sense. There's also so many videos on Khan Academy. If you haven't heard of that, it's K-A-H-N, Khan Academy. And they have a lot of videos on all of this stuff. So if you don't love the way that I'm teaching it necessarily, or you just want to see more examples, you can definitely check them out. And they're also on YouTube. Okay, so let's find my lowest common denominator, or again, any common denominator. If I take 4 times 6, I get 24, right? That would work. But our lowest common denominator, in order to find that, and sometimes it's a pain in the butt, we're going to list the multiples of the number. So 4, 8, 12, 16. Then we're going to do the same for 6. So we have 6, 12, and I'm going to stop there because that's my first one I have in common. So my lowest common denominator is 12. So I get, let's see here, we have a 12. You might hear some barking in a minute, and I apologize. Okay, so we've picked 12, but we could have picked 24. We're going to multiply each term by 12. So this 3 gets multiplied by 12. So I have a minus there. This 2a gets multiplied by 12. Notice how I put the minus in front. It just helps me keep track of everything because this term is being subtracted. Whatever I end up multiplied by 12, notice how I put the minus in front. It just helps me keep track of everything because this term is being subtracted. Whatever I end up here is being subtracted. 12 times 1 over 4, and then a 12 times a minus 3 over 6. So now I'm going to just switch the color here. Whoops, did not mean to do that. Don't think it's matter, but. Okay, so there's nothing, now we're going to look to see if we can reduce these. So 4 goes into 12, so 12 divided by 4, in other words, is 3, and 12 divided by 6 is 2. So now let's write down what we are left with. Sorry, okay, so we have 12 times 3, so that gives me 36. And then we have our 12 times 2, which is 24a. And now we just have a 3 times a 1. So I'm sorry, I did simplify these and combine these. I could have just written them out as is in this step and done it later. Now I'm left with a 3 times 1 here. And then I'm left with a 2a minus 3. So I get 36 minus 24a equals 3. Now, remember, this is expansion, so I have to bring this 2 through. So I'm going to end up with 2 separate terms. So I have negative 2 times a is negative 2a. Negative 2 times negative 3 becomes a plus 6. Now I have quite the mess here. So before I move my numbers over, let's take this 3 plus 6 and combine them. So we get 6, 7, 8, 9. Because this is a plus 6 and a plus 3. So let's combine them just to make my life easier. I'm going to bring my a's to the right side and my numbers to this side. So I get 36, take away 9 because this was a plus 9, and negative 2a plus 24 because it was a negative a. So we get 36 take away 9 is 27. And then negative 2 plus 24 gives me 22a. And then my last step, I'm going to bring it up this way because I have like no room. So we're left, this is what we have so far, is to divide by this number in front of my a. So I'm going to divide both sides by 22. So a equals 27 over 22, or what is that as a fraction? 1 second. That can also be written as 1.23. So either of these examples, or sorry, answers are correct. Now, the problem with the decimal is you lose some of the values. So if you go in and use this to check your answers, it's going to be a little bit off because this is an infinite decimal. So if I'm going in to check my answers, I have to use 27 over 22 for my A. But typically students don't do that because it's very time consuming in these equations. So really just try to look over your work if you've done it and show me as many steps as you possibly can. Okay, so the last example is here for a reason. So sometimes we have fractions that have a letter on the bottom. And when this is the case, my lowest common denominator, so let's think if I didn't have the a, and I have a 3 and a 4, right? It would have been 12, because 4, 8, 12, and then 3, 6, 9, 12, and that's the first one that's in common with them. But we also have to include this letter, because I want to get rid of this letter. So in order to do that, I have to include whatever that letter is. So there's a B down here or an A and a B. The letters also need to be included. Otherwise, it won't all cancel out. So my lowest common denominator is going to be 12a. I'm going to multiply this side by 12a. And then I'm going to multiply this side, sorry, not this side, this term by 12a. And then this one by 12a. So the minus there made me put that. Sorry, it's really hard to, it was so much easier when I could use the PowerPoint and the brush was working. Okay, 3 equals, okay, 12a now needs to be multiplied by this. So this one gets a little bit more challenging. So my a divided by a cancels, and we want that to happen, right? We essentially want to have nothing left on the bottom and everything be left on the top. Unfortunately, I can't really reduce this 12, so I'm just left with a 12 times 1 there. On this one, my 3, so 12 divided by 3 is going to be 4. So I'm left with negative 4a, and I still have that 2 on top. So this one's gone, which is why we did it. But I have that negative 4a here, times 2. Here, 12 divided by 4 is 3. So I get 3a times 3. Okay, so that's what I'm left with. Now let's expand this or simplify it. 12 times 1 is 12. Negative 4a times 2 is negative 8a. 3a times 3 is 9a. We're just multiplying those constants, our coefficients, our numbers together. So let's bring my 8a this way. So I get 12 is equal to 17a and my 17a. And my last step to get this a by itself is to divide both sides by 17. So my answer is 12 over 17, or I will also accept 0.71 as my answers. So again, just making sure if I have a letter on the bottom here, I'm using that letter in my lowest common denominator as well. So that's it for this lesson. And if you have any questions, please feel free to ask me or one of your instructors.